You can check number 6, exponential. We will have a homework check on Friday before we take our test. Number 8. Are there any questions on 6 and 8? Yes. Okay, you might need to try it again. Let me see what you pressed, okay? You should get an error. Number 10. That was a very tough one because the numbers got so close, so you just have to do your best you can on that one. It worked, okay. That's fine, yeah. All right, let's look at 36. This is what we learned yesterday. Our learning target yesterday was graphing logarithms. So I'm going to take my time going through these to make sure. So on graphing logarithmic, we learned the parent function of a log. And we learned that exponential went like this, logarithmic went this. And we understand their inverse because your domain and range is what? Flip. In logarithmic, your domain is 0 to what? Infinity, and your range is all what? Real numbers. Very good. And to be careful when you start shifting things. Alright, so let's look at number 36 here. I had log base 3 of x plus 1. Alright? That plus 1. That tells the graph to move what? Left 1. Will that affect your domain? Yes, so your domain won't be 0 to infinity on this one, really. So what I do first, guys, is I write my 3 original points. Remember, if there's a transformation of moving right, left, up, and down, you got to do your original points and then apply that transformation. Okay, so remember, 1 over b is base, base. 1 over b, comma, negative 1, 1, 0, base 1. So my base in this problem is 3. That's how I got 1/3, comma, negative 1, 1, 0, 3, 1. You said this moves it left, so I'm going to add negative 1 to each of my x's. That gives me negative 2/3, 0, 2. These are the points that I plot. And since I'm moving left 1, I know my vertical asymptote is going to be at y, x equals negative 1. That's why I do not go past that. I don't care where all this goes up here, but that asymptote, you got to protect that. Are there any questions on 36? Okay. Let's look. I want to do 38 and 40 with you. Number 38. We have y equals log base 2 of x plus 4. Is there a transformation in here? So I'm going to have to do my original and then apply my transformation. Okay, so what's my original points? 1 over 2, negative 1, then what? And then what? 2, 1. Okay, that plus 4, is that going to affect it up and down or right, left? Are you going to move it right 4 or left 4? So I'm going to add negative 4 to each of my x coordinates. What's negative 4 plus 1/2? Negative 3.5. Okay, 1 and negative 4 gives me. Negative 4 plus 2 gives me. And those are the graphs I'm going to plot. Alright, so 1, 2, 3. Okay, 1, 2, 3. Oh, 3.5 is negative 1. And my asymptote is going to be at x equals negative 4 now. So my domain would be from negative 4 to infinity. You never have to worry about your range. It's always all real numbers in logarithmic. These are not on your quiz tomorrow, but everything else is. These are not on your quiz tomorrow. Number 40. Do I have some transformations occurring here? Yes. I got to move what? Left or right? Left 1 and then what? So I'm going to manipulate my x and my y coordinates, aren't I? Alright, so I'm going to find my original. My base is 2, so I'm going to have 1/2, comma, negative 1, 1, 0, 2, 1. Now I'm going to add a negative 1 to each of my x. So 1/2 and negative 1 gives me negative 1/2. 1 and negative 1 gives me 0. 2 and negative 1 gives me 1. Now I got to go back in here and add a negative 1 to each of these. That's going to be negative 2, negative 1, 0. My asymptote would be at x equals negative 1 because it moved it left 1. So my domain would be negative 1 to infinity. My ranges, all real numbers. I'm going to do 42 because it's very similar to 40. Are we good on those? Or do we need to do 42? Okay, somebody give me their work they already got worked out. Okay. Let's look at 42. Alright, number 42. We did 1/2, negative 1, 1, 0, 2, 1. Since it's negative 1, I'm going to move it right 1. So I'm going to add 1 to each of my x. So 1/2 and 1 gives me 1.5 or 1.5. 1 plus 1 is 2. 2 plus 1 is 3. Now, the plus 2, I'm going to add 2 to my y coordinates. Negative 1 and 2 gives me 1. 0 and 2 gives me 2. 1 and 2 gives me 3. So that's why my coordinates are here. So I had to do some manipulation to both my x's and my y's. My domain, I moved it right 1. So my asymptote is at x equals 1. 1 to infinity, and my range is all real numbers. We do it for exponential and logarithmic. Alright. Let's turn to page 5 in your notebook. Lynn, can you read our learning target today? I can condense. What does condense mean? Smaller. Expand means make bigger. We won't get through this whole lesson. Tonight your homework is not on this because I'm going to have to use another day to teach. Your homework, you have 4 problems is graphing logarithms again. You have 4 of them tonight. That's it. Alright, so you learned this last year. I want to remember. Can anybody remember a property of a logarithm you learned last year? Starts with P and ends in W. Product rule. When you're multiplying logarithms, you can break it into addition problem. And when you're dividing logarithms, you can break it into a what problem? That's right. So the product rule says this, guys, in logarithms. If you have the product rule, you can break this thing down to log base b of x plus log base b of y. That is the product rule. So I'm just showing you examples of a numerical and a variable. So what does that mean? Like on this one right here, I can break that down to log base 2 of 4 plus log base 2 of 8. I'm just letting you know that is legal. You can do that in math. Here, log base 3 of 3 plus log base 3 of x. Quotient rule. What do you think this will be? Log base b of minus log base b of y. Take that and apply here. That will be log base 2 of 8 minus log base 2 of 4. And then here, log base 3 of x minus log base 3 of 3. Do y'all remember doing this last year? A little bit. Yeah, y'all get introduced to it last year, and this year we really use them. After I get through this chart, I'll slow down because this is just, you should remember this from last year. Then we really slow down in these
notes down here. Now remember power rule. What did power rule say? Take the exponent and put it in front of the what? The log. That just basically tells you that you bring the exponent. If this has an exponent, you bring it in front of the log. So this would be 3 log base 2 of 4. So whenever you see a big number in front of that log, know that it's really the exponent that goes with that number right there. And then here would be 2 log base 6 of m. We're going to save this one for later. Alright. Here it says, I want you to write as a sum or difference of log a span. So what does a span mean? What do you think you want to do with this problem? Break it apart. Alright. So I have a log base. What's the understood base there? 10. How did you know that? Common logarithm. I'm going to break all that apart. Break that apart. 12 x to the 5th y squared. Alright. Now, he said, Mr. Esther, what if there was pluses and minuses in there? Do you see about that 3y plus 2 right there? When you got a plus or minus together, that's considered one unit. You can't break that apart. But do I have any pluses or minuses in that? Okay, you can break that apart, okay? So what you do, because it's multiplication, you're going to put what in between each of them? The product rule says that I can break it apart like that. Log 12 plus log x to the 5th plus log y squared. Now, do you think that's my perfect answer? Where do I need to put these exponents at? In front. So your answer would be log 12 plus 5 log x plus 2 log y. That is what would be considered your good answer. The correct answer. Now, there's a little typo on number 2. I need you to draw that radical all the way over that 4x plus 1. Now, what rule is sticking out to you here? Product or quotient? Quotient, because I'm doing what operation? So I'm going to break it apart. Natural log of x squared minus the natural log of the square root of 4x plus 1. Now, let's stop there because we have several more things we got to do that problem. Do you understand how we got to that point? The first part's pretty easy. What do? Just bring the 2 down in front of what? Natural log. Now let's talk about this. Can you write a square root using a radical? Yeah, that'd be 4x plus 1 raised to the what? 1/2. Because isn't the square root something raised to 1/2? So you got to rewrite it as that raised to 1/2 and then bring that 1/2 what? Down. Yes, you got to bring that 1/2 down. You don't want to leave it with radicals in it, okay? So, this would be 2 natural log of x minus 1/2 natural log of 4x plus 1. Now, you can still leave the 4x plus 1 in parentheses. Now, if you can do that in your head, you don't have to rewrite it as 4x plus 1 raised to 1/2. I just brought the 1/2 down because I know that's raised to 1/2. And that would be your answer on that one. All right. Number 3. What rule stands out to you on this one? Product or quotient? Product, because they're all together. And I can break each one of them up because there's no plus or minus. So here we go. Log base 13 of 6 plus log base 13 of a cubed plus log base 13 of b plus log base 13 of c to the 4th. You're probably thinking, what's the purpose of this, Mr. Esther? Okay, here's the purpose of it. We're going to start equations next week, and you have to know these properties to do equations. So this is just letting you practice using these properties. Now I need to do some power to power on this.
So log base 13 of 6 plus 3 log base 13 of A plus log base 13 of B plus 4 log 13 of C. That would be my answer. Number 4. Can you split the 3y plus 2 up? No. So I would do natural log of 3y plus 2 minus the natural log of the cube root of y. Now, how are you going to respond to that cube root of y? Put a 1/3 out there, natural log of y, and that would be your answer.
We're going to do one more and call it a day and finish all this tomorrow. 5 is a little more difficult than the first 4, so let's think about how we are at the first 4. Are there any questions on the first 4? Number 5 is different because if you look in the denominator, are they joined by a plus or minus? That means you've got to break the 2 up. And when they're side by side, that means what operation? Multiplication. So you have the product rule and the what in this problem? Quotient rule. So you would do log x to the 3rd plus log y to the 4th minus log z to the 6th. And then just bring those power down in front, and that is your answer. You could, but I've never seen it in a textbook like that. It's always been like that. Yes?
So you would break apart the numerator first and then...
Mm-hmm. Yes. Yeah. Alright, we're just stopping there today? Okay, you only have 4 graph and logarithm. You can do that before you leave school today, okay? This is the last new thing that's on your test Friday. So we're going to do this tomorrow, review, test Friday. And then spend a week and a half on just equations.